So up to this point, we learn how to take the derivative, mainly polynomials, use like, x to the 7 plus 7x squared plus 1, something like that, right? So these are nice functions that they're polynomials, or e to the x, right? Something like this, or even e to the ax, a could be 0.1x, something like that, right? Um, so what happened when the polynomial is written in the factor form or written in the power form like this here, where you have x squared plus 4 raised to the third power? Well, one suggestion what we can do to find the derivative function of this is to expand this out 3 times, right? That, it's a lot of work, but it's certainly doable. You can just FOIL this and you get whatever that answer is. You're gonna get around at least 7 or 8 terms there. But what if our function is not just raised to the third power? What if we have x to the 4 plus x squared plus 4 raised to the third, and then you have another one over here as x plus 1 raised to the 10th power, something like that. We don't want to sit there and simplify this and then take the derivative of each term, because getting to the simplified part will be not fun to do so. Okay, that's where we look at new rule to be able to do this much more efficient, so we don't have to expand it out and FOIL it out over and over again. So these type function is called composite function, meaning we have the inside function, we have the outside function. So if we have a function, let's say if we have f of x, in this case it'd be x to the third, right? So that's a function just by itself. But then now if we compose f with another function g, where g itself is an x squared plus 4. So when we compose the g of x inside of that, then the g of x now becomes the input. And then now we have the f composed g being x squared plus 4 raised to the third. So the chain rule become very useful for composite function, and that's what we use to find derivative of composite function. So the rule said that if you have a function that is a composite function, then the derivative of that function is equal to the derivative of the outside function multiply the derivative of the inside function. So we said d dx of outside function. By the way, d dx is short for derivative, multiplied by d dx of inside function. So now the main task is, how do I recognize a given function where I can extract what's inside function, what's outside function, or what is the parent function versus the inside function. So that's where the task is. How do I recognize that first when I applying this rule here? So to do this, to understand this section 3.4, you have to be able to master these derivative rules before this section. That is the power rule. Okay, the derivative of e to the x, derivative of natural of x, product and quotient rule. Okay, so these are the derivative rules introduced before this lesson. So anytime you struggle in this section, I would encourage you guys to go back and review these rules first, or do these sections before you do this one. When I teach this class on ground and students can't really have open book or open notes, on quiz exam, what I started doing for the past couple of years is allow students to have this index card, and they can use in quiz notes. And the index cards is just mainly just what the student used to write down all these rules that they learn, formulas and rules they learn throughout semester, and had them handy so when they do a problem, they can recall to this rule. So, if you don't want to sit there and flip through pages of notes and homework, you can start creating flashcards as you go. Every chapter, every section, there's a new rule. You want to write down the rule so that way you have it handy or right next to you when you need to recall to it. So when you look at example 1 here, these functions are much more complicated to look at than the one we've done before. You have a polynomial function that is composed within the negative fifth powers, and then you have the e to the x where the powers is a polynomial itself, and then you have the natural log functions, and then the input or the arguments is another polynomial itself. So these are composite functions. So we ask to find the derivative of these functions. Okay, so let's do it. Okay, what will you say the inside and the outside function for a here? Okay, what will be the inside function? Well, the inside function is going to act as this input here being raised to the fifth power. So the outside function is going to be negative fifth power. So we can say inside, if you don't, yeah, you can just do inside is 2x to the third plus 4. And then you can say outside is x to negative fifth, right? So when we apply the chain rule say that first we take the derivative of the outside function. Okay, so what is the derivative of the outside function? Is a polynomial, so we applied the power rule, and the power rule say, hey, I'm going to bring down the power, and then I'm going to take the power and subtract it by 1. Okay, so that's the derivative of the outside function. So now we're going to times it by the derivative of the inside function times. Okay. The derivative of the inside function is 2x to the third plus 4. Well, the derivative of that, so I'm going to go ahead and write that as one extra line. Okay, d dx of the inside function. Okay, so this right here, this is remind me that when I use the chain rule, I do the derivative of the outside first and then multiply the derivative of the inside. So d dx of 2x to the third plus 4 is just a step that we remind ourselves. Once we get good at this, we don't have to write this step more than once here. So now we say, okay, well, this is going to be negative 5, 2x to the third plus 4, negative 6. Well, d dx of 2x to the third plus 4, using the power rule, that's just 6x squared, right? You guys agree? So now we just combine the negative 6 and the negative 5 and 6, so that becomes negative 30x squared, and then 2x to the 4 raised to negative 6, and that is the derivative, okay, of this function mx. Let's do another one. Let's do C. Okay. All right. So who can tell me what is the inside and the outside function?
Is there no outside function? Only the inside function. Outside function is, we can say 1.
Anyone? The way we can tell whether we know which function, which part is the outside inside function is what is the first thing we do to the input versus what is the last thing we apply to the input. So if we're looking at C, when we start picking input, meaning x, if we pick any x number, what is the first thing we do to the x here? We square it, we plus 9 times that, and then we plus 4. So that's the inside part. And the last thing we do is we apply the natural log to it, so that's going to be the outside function. Okay. So ln of x is x squared plus 9x plus 4. Okay. So using the chain rule, m prime of x okay, First, we apply the derivative of the outside function. So the derivative of the outside function of ln of x is 1 over x, but the x now is the argument, the inside, the input of natural log of x. So what is being fed to the natural log of is the x squared plus 9x plus 4. So think of this as your input x here. Okay, so the derivative of the natural log is 1 over the argument, and the x now is x squared plus 9x plus 4. Okay, so that's the argument. Multiplied by the d dx of the inside function, which is x squared plus 9x plus 4. Okay, so we have 1 over x squared plus 9x plus 4 times d dx, that would be 2x plus 9. So now our answer is 2x plus 9 over x squared plus 9x plus 4. And that is our derivative function. Let's do the part B here. M to the x of, so part B, m to x equal to e to the powers of 3x to the 4th plus 6. Okay. So how do we know where we apply the chain rule versus we don't? Okay. So in this case, it's a composite function because it's not as simple as e to the x. Okay. So if it's just e to the x, the derivative is just e to the x. This is e to the 3x to the 4 plus 6. So the input of e function is being modified to 3x to the 4 plus 6. So this is when we recognize, okay, this is where we have to times it by the derivative of the inside function, or we have to apply the chain rule there. So given the fact that, I guess most of us haven't quite got to this lesson, these problems can be intimidating. But once you walk through the first couple lessons and then you get to this one, it shouldn't be as complicated, but it's still confusing because there's so many new rules in this chapter. So just hang in there. So anyway, get back to this problem here. Who can tell me what is the first thing that we're doing to the input x there? What's the first thing? What do you do to the x first? All right. Nobody? Well, the first thing we do to the x is raise that to the 4th power and times by 3 and plus 6. That's the inside part. And then after that, we apply e to that, the result. So the inside function now being 3x to the 4th plus 6, and then the outside being e to the x. So when we apply the derivative rule, the chain rule to this, first we take the derivative of the outside function, which is e to the x. It's going to be the same thing as that. Okay. But then we have to times by the derivative of the inside. So now the answer is going to be 12x, rewrite that, and we get 12x to the third times e to the 3x to the 4 plus 6. Do you guys have any questions so far? I know this could be intimidating right after you took your exam and still kind of feel the motivation to start off with the new homework. But we are moving forward and things will get a little more hectic from now on. A lot more rules coming your way. Okay. All right. Well, it seems like I'm gonna let you guys go and attempt these first couple section first, and then we'll see you guys tomorrow if you have questions. I hope you guys have questions because the longer we put this last minute, the more stress we're gonna feel. So I will end the meeting now, and I'll see you guys tomorrow if you decide to come back tomorrow with some questions. All right, guys. I will see you guys tomorrow.